You can Pascal as well then. You can start without Pascal.
Yeah, we can start.
Without Pascal?
Mm-hmm.
Can we start without Pascal?
Yeah.
He's our first speaker.
Well, but we can switch because we have 1 hour. Okay, so we can start now, actually, right?
Yeah, we should start.
Yeah. Hi, good afternoon. This is the roll meeting. We're going to start because we have just 1 hour, and I think we have new work to discuss. Okay. Please read and be aware about the not well. Apply for this meeting. We have the meeting materials already in internet. Thank you very much to Dominique for the minutes taker and Pascal that should be appearing in a moment. And thank you very much, Michael, for being JavaScriber. Please sign the blue sheets. Okay, this is our agenda. Okay, we are going to have the state of the working group at the beginning. And then Pascal is going to present the projection work. Then Raul is going to present about optimization. And we are going to have a newcomers presenting, Mamoun, about the load balancing work that he proposed in a paper, and he sent to the mailing list last year, the paper. And now he had to write a draft on it. It will be nice to have comment about that as well. And Charlie is going to present the LDB Ripple work. And at the end, Michael is going to present the update for Ripple information that this document is in working group last call. It would be nice to have your opinion about that. Okay, we have since December last year a new charter. So we have new work that was included as working group item. And some of them is going to be presented today. Our milestones. We have a charter, and you can see we have initial submissions, and we are some kind of delay with this guideline for use cases. So it will be nice to move on with this work. The state of active internet draft. We have one RFC edit queue, the routing dispatch work. We have 3 presentations today of the working group items. Okay, yes, we have a new RFC, so thank you very much for the authors for the work. We have open tickets that Michael writes, and we created for the projection work. And we have related internet draft. This is not updated in Mexico. Okay, we have the modifications that's going to be presented by Raul. Load balancing that's going to be presented for Mamoun. And we have a similar document, Ripple parent selection, that's not going to be presented today. Is the author here of this work? Is the author here? Okay, no. We have an energy optimization work as well that was submitted. Okay, Pascal, please. Is okay for you? Thank you. He's going to present the DAO projection work. Oh, thank you. Oh, okay, thank you. Please, Email.
Okay, so this is Pascal Thubert. Closer? Yes. Well, if you won't like the noise. It's not working so well, is it? Okay, anyway. So this is about the DAO projection work, which is now workgroup document. And if this worked, that would be even better.
Oh, wait, I'm sorry, I didn't.
Oh, yes. Sorry. Okay, next slide, please, anyway. So I thought there would be very little changes in this document up to like a month ago, and then Raoul came in and suggested that we actually include a source route mode into the projection thing. So I went up and did what I thought would be the slight addition to say, oh, the state you have to populate is now a source routed state as opposed to a classical route. And that ended up in a major reformatting of the document. A lot of the examples which were part of the main text are now in annex. So the main text focuses on the protocol itself. And we have now what is analogous to storing and non-storing modes into the DAO projection. But the way the draft is written right now, and with the use case in mind, there is no direct mapping between how you do the ripple for this DODAG and how you do the route projection. So the way the draft is written right now, you could be using source routed analogous to non-storing projection inside a storing mode DODAG, for instance, to establish a shortcut between east and west. So that's something I would like, it's just brand new, so I'd like people to think about it. Is it valuable to say, I can project any sort of route mode, quote unquote, into a DODAG which is of any sort, which enables you to have what we did initially, using some storing mode into a non-storing DODAG, just to shorten the source route, but now using also source routing to do a east-west route, to do a shortcut inside the DODAG. I think it's very, very powerful, but if people are fine with that, then it's a good time to talk about it. Also, since I added the mode where you've got a source routed path into the projected DAO, we have to make a difference between what is a projected case with source routing and what is just a sequence of hops. So the way the draft is written right now is, if you have one via option with multiple addresses in them, sequential addresses, it means a source route path. If you have multiple via options with one address each, then it's a normal route as the draft was using before. Then again, it's just one possible representation if you have ideas about how that could be put in the options and how the options could be placed into the message. And hopefully I'm interested. One problem I faced when I wrote that is how to compress this. Because before we could say, hey, it's a single address. So by the length, you see how you compress it, basically using similar rules as we have in 6LowerH. But now, since you have many addresses, the length is not informative. And so we would need to, I think we would need to find a way to compress the source routed via option. Peter?
Hi, Pascal. Peter van der Stok. I like the way it is presented now. I think it's much better than before. But there's one thing which I was missing. Can you hear me? Okay. Was one thing which I was missing, what was consideration of local space when you start entering your tables. Do you think that is necessary or? Okay.
So basically, Peter, if I understand well your question, if I may rephrase, is we expect that the root has enough information about the capabilities of the node so that it can inject an amount of routes into this particular node that the node can cope with its amount of memory. Is that, yes. And right now, and that was a discussion from Michael as well, the solution would be complete if we can effectively have this information. And so far, I consider that this was out of scope for this draft, and that there would be some external means like management, like hard coding, whatever else, or a YANG or external controller which would tell the root about the capabilities of the nodes. For instance, if it's a mesh with all the nodes which are exactly the same, then it's pretty easy for the root to know about the capabilities of the device. Now, if people want something more dynamic, like each device may be different, each device may be loaded by multiple things, meaning that maybe the amount of routes that it can store varies dynamically, then obviously we need a protocol between the device and the root. And well, that's again the feedback. I mean, we can design one. I'm completely open to that and say it's It's a new option. Mostly if you think about non-storing mode. In non-storing mode, the device talks directly to the root anyway. So we could have a new option about device capability. So if people care for doing this, just let me know and let's discuss that on the mailing list, come back through the mailing list and let's start this discussion. And yes, this document could very well hold some information like this. And last but not least, when you do this source route, this new source route mode, which enables east-west, there is one thing which is, again, this IP and IP discussion of, since now the packet will reach a device, and the device will have this DAO projected route, which will say, hey, now you need to encapsulate this packet, and well, you need to add this source routed header in front of it. If we follow the rules, I mean, that means, again, IP and IP, right? And so that's perfectly fair in some scenarios, but I realized that there's one scenario that's also very attractive in which it's not what we want. So I've not documented that scenario in this document, but the scenario goes like this. Say I have a 16 hops route, and I want to populate source route path of 4 hops 4 times. You see? And so the root would, every 4 hops, it will install a source route that enables to go 4 hops deeper. And so by adding just 4 addresses in the initial source route, you would actually enable going 4 hops at a time, you know, going all the way down. But when you use this, what you really would like to do is, when you consume the first address, you replace it by 4, and you forward. And then as you go down, you know, with 6 lower edge, you consume them. So you go down to 3, and then you replace the first one by 4 again. Then you go down, 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 and you replace again. That's actually a very cool mechanism. But if we do that, we virtually replace one address in the source route header by 4, which is not encapsulation. It's a different mechanism, right? Basically, it's implicit. The root wanted you to go all the way through the 16 path. And it has established like a compression mechanism all along. And expansion of one entry really means adding 4 headers, 4 hops. I really love this mechanism. I just wonder if you want it in this spec. And if you want it in this spec, it's not an encapsulation thing. Well, I don't have it in the spec. I would like to discuss it, basically. And that's pretty much still doesn't work. So
Oh, sorry.
or maybe it's not on. Let me check. Yes, it is on. Let me put it off and put it on again.
No, but I changed.
Oh, no, you know,
Okay.
I just reset it and now it works. So that's basically the number of discussions that we had. So how is topology known to the root? If we are doing storing mode, the root knows the DODAC topology, but it does not. It does so that's south to north, but it doesn't know device to device topology. So all the hops that could be used for east-west. So how do we address that? If we are using storing mode, the root has absolutely no idea about the topology. So in any fashion, if we want this to work, there must be a TIS-like a Ripple TE protocol, which enables the root to know about all those additional neighbors. Then the question we just discussed, that was your point, Peter. How do we know the node capability? And is the concept of having mixed storing and non-storing between the projection and the main DODAG, is it a problem or not? So, and the last point is the one I just explained, right? I mean, expanding one entry into 4 entries. So all those points, I mean, if you have any idea or if you could come back on the mailing list with some comments on that. I know it looks pretty strange because this is kind of a new world that we are exploring together, but there's a lot of power behind all those things. And how, because it's your fault, I really expect you to come back and comment. And thanks for this, actually. So if I have time left, but I don't think I have. I have a few minutes? Okay. So basically, I added just some examples of how the new mechanism, the non-storing, quote unquote, the source route path that's injected by a DAO projection could be used to enable peer-to-peer communication. So there we go with the mesh. And this is just showing what we got today if we are doing path between two nodes. In this case, it's 51 to 53. And we are in non-storing mode. As you know, in non-storing mode, you have to go all the way to the root anyway, because only the root knows how to go down to any device. So you use the default route all the way up. And then there is a source route path, if we are using non-storing, that goes all the way down to node 53 here. So the packet goes whoops, and whoops, and that's exactly what we want to avoid. So say we've got this industrial operation, they are doing, say, 6 dish or whatever for collection tree, REPL is very efficient, and all of a sudden we want to establish, they want to establish a control loop between those two guys. It's not possible to do a control loop all the way through. It will fail. We want to have a shorter path with better quality, and that's when we want to establish this direct east-west route. So if it was storing mode, the stretch is a bit less, but in this case, it's still quite big. You have to go all the way to a common parent, then the common parent has a storing mode route, and the packet code can go down. So this is very much analogous to spanning tree. So now say that we have this new projected DAO with path segment, and the segment indicates that the target is 53, so we are going here, and it's via 41, which is the ingress of the tunnel, 42, and then 43. Okay, so basically 41 will be told that if he goes to 53, he must put a source route header which says 42, 43, 53. That's what the root tells him. And that's I guess that's the alternate. I wonder what this slide is here. Yes, if we are doing it in, oh, okay, this is the storing mode slide. I thought I was doing non-storing here. Okay, no, I'm sorry, I thought I was doing the non-storing DAO projection. This is storing mode DAO projection. So this is when you establish real routes. So you basically, this is the mechanism that we were already aware of with the previous document. So basically we are building an east-west route in order to go to 53. So 43 forwards the information to 41, which acknowledges to the root. That is the classical way of doing the projection. And the optimized path ends up being this. Right? That's what we could do with the normal projection thing. So now, if we want to use what we have just added to the document, what we do is we inject a path segment to 46. Oh, no, that was actually the previous thing. Oh. I thought I added. I'm confused by my own slide. I thought I had an example of source route encapsulation there, and I don't see it. Is it really the latest? Yeah.
Really? 1 minute.
Okay, so I will do it manually, because I thought I had the slides right. So basically what's going to happen when we do the source route thing is that if we want to establish a path, between 51 and 53, basically the new DAO projection will be sent only to 41. And this DAO projection will indicate that you have a segment via 42, 43 to go to 53. Okay, and that will cause, when the packet from 51 arrives in 41, 41 will look up its route table, find that you have the source routed path, and it will have to encapsulate the packet, saying the next hops are 42, 43, 53. If you remember the way the 6-layer H is built, you just write them one next to the other, the final destination being the last in the routing header. Maybe it's there, but I just don't recognize it. Okay, so either way, you can build a east-west route. In the first case, it starts from 43 and the acknowledgement goes all the way as it was done before. With the new mechanism, you just put it to the ingress of the tunnel, indicating what the egress of the tunnel is, and the intermediate stops.
Yeah.
I'm sorry, I should have told you something. Anyway, so you figure out what that is, and you will find in the meeting material the animation which shows that. But it's not very surprising. I mean, just figure that the way it worked before, you send to the end of the segment, and you go all the way up to the beginning of the segment, which acknowledges. With the source route mechanism, you send to the beginning of the segment, which will encapsulate with all the hops to the destination as a source route header. Well, anyway, people
okay.
can look at
This
it
one?
later. Yes, we're past. You have a question, Rahul?
Rahul Jadhav from Huawei Technologies. So one of the complexity that I see with this this mixed mode is how to handle DAG inconsistencies. For example, I mean, let's say there is a loop, because now we have a storing mode mixed with the non-storing mode. And if there is a loop, now loops are possible.
Storing and storing.
Yes.
Because if the DODAG is non-storing, since the root handles everything,
Yeah.
it's not supposed to happen, right?
No, but if it tries to invalidate the path before the lifetime expires, then
One way of addressing this would be that the new DAO injects a route along a certain path. So in classical terms of the routers, you could say that there is an administrative distance associated to this routing protocol, which is better than the administrative distance associated to the main DODAG. Which means because you are because
Yeah.
normally the segments take you to the destination, but maybe not.
yeah, I think
Let's
I think we
work
can
that
think
out on
about
mailing
this complexity, because the only problem that I see here is, in case of pure storing mode, there is a way to handle these inconsistencies, but here the node can't really send a DIO and sort of handle these inconsistencies, refresh the DIO and handle this inconsistency.
If we can detect it, let's discuss that on the mailing list.
Yeah,
because I've
sure,
not
sure.
thought of,
Yeah,
of
yeah,
that,
yeah.
detecting loops with the mix, all storing. So let's discuss that.
Okay, thank you, Pascal. Yeah. So, Raul is going to present NOPAD DAO for Ripple storing mode of operation. Thank you.
So Rahul Jadhav myself. So this draft has been presented for the first time in Buenos Aires. So basically I've been concentrating primarily on the problem statement. So if the route invalidation doesn't work optimally, then what are the problems? So for all the previous drafts were sort of handling those problem statements and specifying the requirements from the solution point of view. What is the latest update is we have a solution. Turns out it may be very simple to handle this invalidation much more optimally. Thanks. Okay. So, okay, before digging into deep, the first thing that I want to say here is there is a lot of care that has been taken by Ripple to form the routes, but the similar care has not been taken. Similar design consideration has not been given to remove the routes. And that is what essentially this document sort of works upon. So one of the basic premise that this document works upon is that the NOPAD DAO follows a path which the node decided no more to work on. For example, in this case, if you see, node D, once it switches path from B to C, the NOPAD DAO is expected to be sent on this path. So essentially what it means is NOPA DAO is going to be suboptimal by design. So what are the problems with this suboptimality? So these are the 4 problems that are listed here. First is the NOPA DAO messaging depends upon the previous. So this is one of the characteristics. So let's say the D switches the path here, then E and F, which are the dependent nodes here, there is no invalidation on behalf of E and F. By the way, just to make it clear, this problem statement and this solution takes care of routing mode of operation only. So these problems are not there for non-storing mode of operation. So yes, this has to be very clear. So the first problem that it sees is that the NOPA DAO takes a path which it decides not to use. Dependent nodes, there is no route invalidation mechanism for dependent nodes. Third, the NP-DAO and DAO are asynchronous. So an NP-DAO is sent from another path, DAO is sent from another path, and it might so happen that the NP-DAO clears up the routing state along the way till BR, while the DAO is still getting retried here. So there is a chance of route downtime. The fourth point is it impacts P2P traffic. So for example, if the NOPA DAO doesn't succeed here, then node J, which is trying to send traffic to E and F, will have impact. So this P2P traffic is going to have an impact. So the whole of this subtree is going to have an impact when it comes to P2P traffic. This is working. The laser point is working. Okay. Yeah. So the solution turns out it is much easier to handle this problem. So if you see here, this is the previous. This is the current NP-DAO mechanism, and this is the proposed change. So what happens is in the proposed change, we are saying that when node D sends a regular DAO with a lifetime greater than 0, it reaches A. Now A is the common parent for both the paths. A knows that there is a change in the next hop here for the target D. So node A originates the NOPA DAO on behalf of target D. There is a state information in the form of path sequence here. So basically the state information also can be taken care of in this. So the basic proposition here is that the route invalidation is initiated by the common parent on behalf of the target node. Having said that, target node would still be in control of its own invalidation in the form of, let's say in the regular DAO, it sets a bit saying that, okay, if there's another path for me that was set previously, then common parent might want to change that path, invalidate that path.
Excuse me, Raoul.
Yeah.
Pascal, we are here. Could I clarify a question because we are taking notes and I'm not sure I understood correctly and I don't understand the same thing as the other note taker. So just to make it sure, is your proposal to have A send a packet to G so that G cleans up? So it's a new message that goes down the other path.
Yes,
clean up thing.
That's right. So NP-DAO, as of now, the semantic was that it goes upwards in all the cases, but now it goes downwards because node A it knows that the previous path was through G, and G will send it further down using the routing table. Previously, it was using the default route. It will now use the specific routing table entry to send it down.
Okay, so you basically prune a broken branch.
Sorry?
You are pruning a broken branch.
Yes.
By cleaning up all the
That's
way.
right.
Okay.
That's right. Yeah. Okay, from the solutions perspective, now if you see the NP-DAO messaging now follows an established path. So ideally it should be definitely more optimal than whatever is there currently. Secondly, the route invalidation for dependent nodes will also work as it is. So for example, when node E and F in the previous slide would have sent a regular DAO on its behalf, they could have also requested. But having said that, right now there is no way that node E and F knows that node D has switched the path. Currently there is no way. Having said, but it is possible for node A to know that E and F there would be a stale state here, so it's better to clear it up. So dependent node route invalidation is also possible here. Possibility of route downtime is now negligible because now there is a synchronous operation between the DAO and NP DAO. So
I had a question about that part. So does that mean, I guess you need your diagram on the previous slide again. Does that mean that A doesn't install the route through C until it's cleaned up the route through B?
no.
No.
So what happens is the DAO
Right.
reaches A. Now node A sees that the next hop is going to change.
Yes.
So now it just uses the next the previous next hop
Yes,
and
which
sends
is-
an NP DAO towards
And
it.
it sends it down to the G. That
Yeah.
prunes off that branch. So
Yeah.
I guess I'm trying to understand if B had traffic or J had traffic for D or E or F,
Yeah.
once the NP DAO gets to G, it's going to go back up
Yeah.
the route
Yes.
there.
Yes.
And so, and at that point, A has already switched its traffic to D, so that's why there's no downtime, because as soon as you kill the route,
Right.
then you're there.
Yeah.
Prior to that point, so if the traffic, the NP DAO is still traversing from A to G, when J sends his traffic to G, well, that traffic gets lost, but we have no choice. It's
Yeah. There's
going
no
to get
choice
lost
there.
anyway.
Yeah.
Right.
Yeah. Yeah. So it improves the situation. And turns out, sorry. Yeah.
Pascal, just to let you know that if you look at the design of the backbone router that is now working on document at 6low, when a device moves from one backbone router, one route, one DODAG to the next DODAG, there will effectively be an exchange through ND over the backbone, which will tell the route of the old DODAG. No, I'm here, I'm on DODAG A, I move on DODAG B, and now I'm registering through REPL to the route of DODAG B. The backbone router will ensure that the route of DODAG A knows that. And the design was exactly made so that we could do what you're doing here, which means that's exactly what we need for that situation. I don't know if I'm clear, but I'm very happy. Okay, again,
Yeah.
2 DODAGs, boom. The guy was here, now he's here.
Right.
Stelrod's here.
Yeah.
Because what you really want to do is have the packets go all the way to the backbone, through the backbone, down the other DODAG. That's what you would like to see happen.
Right.
Until this is cleaned up, you're stale. And there is no path now, there is nothing.
Right.
You
Okay.
don't even have a common parent, it's the root. Okay? So what happens through the backbone router document, the draft which is at 6low, is that through ND exchanges, this root will know that this root now owns this address.
Right. Okay.
It will tell so. And the intention, there is a special written code for that, is that the root goes and clean up all the way.
Okay.
And we were missing the tool for doing this, which is
Okay.
exactly that.
Okay.
So
So as I understand here, so
it's not a
so
question,
this-
it's just to let you know
yeah,
that
yeah,
we
yeah. So,
expected this,
I'll
we
go
wanted this.
go and have a look at that draft as well, to the backbone router, right? So the work in the 6low.
Because this is a component that was
Right,
needed
right,
in
right,
that whole
right.
story.
Okay. Thank you. Thank you.
Rahul, can you conclude, please? Can you conclude?
Oh, okay. So turns out that this also reduces the NPDAO control overhead. Now the NPDAO does not have to go all the way till the border router. It just has to go from the common parent to the impacted node, to the target node. So it also reduces the control overhead. Now the suggested changes are, first, an invalidation bit. Now this invalidation bit is sent in the transit information. It's a new I flag which says basically this is sent as part of a regular DAO, which informs the common parent that you can invalidate on behalf of me. The second, this R flag this is part of the DAO message. Now this is required because an NPDAO now has to go downstream. All the NPDAOs currently go upstream, so there has to be a flag which says that the NPDAO has to be sent downstream. So this is essentially that flag. The name is reverse flag, yeah, reverse NPDAO. Yeah, that's it actually.
Thank you. I think we are off of time. Please read the draft and comment on the mailing list. Now, Ramon is going to present his new proposal. I'll take it. Yes, working.
Okay, hi everybody. My name is Mamoon from Edinburgh Napier University, Scotland. Is that better?
Take them.
I'm gonna present my draft today about load balancing in RPL. Just to highlight one point here, that this contribution and the idea of it, I already presented at 2016 October in IEEE conference for standards and communications and networking. So it's already online since that time. Just to begin, up to now, two objective functions and couple of metrics have been specified in RPL to optimize the selections towards the route. However, we think that RPL still suffers from unbalanced and unfair distributions of number of children among the candidate parents. And that consequently, the overload parent node would drain its energy much faster than the other candidate parents. And that might result in early disconnections, part of the nodes that is covered by the overloaded parent. To show this in example, from this figure, we can see that node 3 and node 2 are the only node within the coverage area of the route, and 7 and 8 within the area of 3 and 4 within the coverage of 2. However, 6 and 5 within the shared area between 2 and 3. So the selection, as we can see here, 4 selected 2, and 7 and 8, 6 and 5 selected 3. 3 and 2 are the same rank. And because the DIO, 6 and 5, received the DIO from the 3, so it selected 3 as a preferred parent. Now, that's okay. As we can see there, that the number of children for 3 is 4, for 2 is 1. Now we ask if we increased and how to force 6 and 5 to select 2, under which condition. So we think that if we increase the number of children within the area of 3, okay, maybe we can force or allow 6 and 5 to select 2. But the answer, as you can see, is not. So now 3 is overloaded with not 10, by mistake, it's 12, and 2 within the shared area. So 3 is overloaded and 2 just left with 1 child. How about if we increase the number of the nodes within the shared area between 3 and 2? So we increase this, and as you can see, even so, still 3, all the shared nodes selected 3 as a preferred parent. Now, 3 dominated all these nodes within the shared area just because these nodes received DIO from 3 before 2. Now, as we can see that 3 now has 18 children and left 2 only with 1 child. And definitely this there's an impact on the reliability, and it will affect the reliability negatively. Yes, Pascal.
I have 2 remarks here.
Yes.
First, there are 2 things really that you could be looking at is, because you're talking about saturation, I mean, getting, as long as, node 3 works perfectly to send the traffic through, after all, it's not a problem. But if node 3 starts having problems getting the traffic through, it may be coming from 2 reasons. First, you are in storing mode and too many children, not enough memory, you're screwed. And we discussed that case. We did not really do it in the first release of REPL, but we said, oh, we could have a written code in the DAO, in the DAO hack actually, to say I'm saturated, I can't take more routes, go see somebody else. Okay, that was just to address the storage in node 3. And then there is the capacity of node 3 to transmit traffic to the root. And this is, well, this is really related to the amount of traffic, not to amount of children. The amount of children is only indirectly related to the amount of traffic. It could be very well that node 4 here actually drains all the left of the network, and actually it's more packets coming from 4 than all what you can see from your route in the right. So at some point you wonder, hey, what is it, which saturation am I working on? Am I working on the DAO storage saturation or the throughput saturation? If you're talking about the throughput saturation, I would advise to use the throughput as the metrics that you're working on, not the number of children, because it may or may not be relevant, and you can't know if it is. Now, I have a question for you on this particular design. If you experiment with this, do you see ETX on the right going down? Because I would expect that if node 3 has a saturation going to the root, it can't push all the packets, and ETX will go down. And if ETX goes down, there will be this imbalance that will move devices to the left. Just for the pure virtue of ETX as it stands, without requiring to have a new something. Okay, so morality of what I said, if you're talking about DAO storage saturation, it's one thing for which this is useful. If you're talking about throughput saturation, it's probably not the right tool.
Okay. You pointed to the DAO here, okay? And the DAO still, as according to the 6550, is an optional feature in RPL, even the acknowledgement as well. So here we are dealing with the upstream, if you, or upward, if you like, both, or during or while the DIO is maintaining, or okay. So yeah. So if the application doesn't, doesn't support the DAO, or the DAO is not activated. So just to answer your first part of the question, okay? So you cannot count. But regarding count the number of children. But regarding the traffic that you highlighted here, yes, it is indirect, as you said, but at the same time, it could be direct. The ETX, yes, will be affected with this traffic, could be, but which is the better? To omit the number of children from the beginning, or to consider it? So I think, and I believe, that considering the number of children in the selection of the parent is a good and advantage for optimization this selection, to optimize this selection. So considering, along with other metrics, such as with ETX, with number of hubs or whatever, okay, this will boost and optimize the selection of the parent better than omitting it. Yes. Yeah, I'm still in problem, but I'm just trying to. Okay,
so you're saying for the initial formation and not for the dynamics of the network, right?
Say again, please.
You say for the initial formation of the graph, not for the dynamics of it.
Yeah. Yes.
Yeah, because the other point is REPL would really encourage you, all those nodes in the middle point, to have the two parents anyway.
Yes, that's clear.
And it would, if you have an imbalance, it would basically push you to use the.
That's true, but here from this figure, as you can see, suppose that 3 drained and consumed and became dead. Now those nodes within the shared area, okay, it will be handed to 2. That's clear. However, those nodes over here, oops.
You did it.
Give up with the solution.
Where's the reason?
Come.
Yeah, so those nodes, sorry for this interruption. So those nodes will be disconnected from the network because this node is the only gate towards the
I used to do a
sink.
solution. Yeah.
Yeah, I want just let me address the solution and I will back to you as
Okay,
Yes,
yeah.
that
we've
will-
read the draft.
They-
We know your solution. Can I jump forward? Well,
Maybe
you just
not everybody
Dominic
knows.
Bartel with Orange Labs. You just mentioned that the node 3 will run out of energy and then the network will become disconnected. Just remind you that 6551 has the possibility to have multiple metrics in a row. So you could have remaining energy of the node as a secondary metrics, and then nodes will
Well-
switch to node number 2 and problem solved.
I use that, but it doesn't work as you expected to do. Let me just finish it and take your time after that. No worries. Sorry, Rahul.
Cut to this
And
queue.
to tackle this
Sorry.
problem, okay, I think, okay, we should consider the number of children, okay, in the choosing or to optimize the selection of the preferred parent. Now, what kind of considerations I will speak in this in a couple of minutes if the time allowed me to do that. And so we propose a new metric here called number of children, never used before. It's a novel metric, okay? And so now the challenging is how to allow each node to prefer its own number of children without introducing any new messages that definitely will cause more overhead. So from this graph, as you can do the instructions in A, okay, this message or this node sends its own DIOs, then received by 4 and 2. B, 2 as soon as it's received, okay, select its own preferred parent, which is in this case the root, and calculates its own rank. After that, broadcasts its own DIO to all neighbors, which are those neighbors, including the selected preferred parent. And the same thing in C and D. So we have here this DIO. Normally in RBL, it is ignores. It's ignored because the rank of this node is much higher than this. And we said, okay, we have here DIO can be utilized. These DIOs, okay, can be used wisely, and we injected the IP address of the preferred parent inside the DIO. Once it is received by the preferred parent, can match its own IP with the injected or with the selected parent address. If there's a matching, then it can count 1 and so on and so on. And this is exactly what we did. So we used this. This is the format of the current DIO. And according to my draft, we just followed what Pascal kindly suggested. We injected the IP address of the parent inside the option. And this is the proposed option that we have it here. If there is a matching, then it can be count 1 and 1. So this metric, which is counted, okay, can be taken to the metric container and along with another metric such as ETX, such as number of hubs, to optimize the selections together. And this is the expected distributions after considering this number. As you can see here, it is better than the previous situation. So may I ask which is better, to consider this, okay, or to go for this, or to keep the previous one, considering if there is, back to Pascal's point, that if there is overhead regarding the traffic from 4, okay, then the ETX will balance this, okay, without any problem. Yes, Pascal.
Pascal again. Well, you're choosing between two trees, and the second tree looks better, but Ripple really builds the ODAGs. And so in practice, 42 will be attached to both. So it's kind of the best of both worlds already, right? It's true for the preferred parent selection, right? So, but the preferred parent may evolve with the traffic. You're talking about the initial topology. I would say 42 would attach to both of them. So,
okay. Let us conclude on this nice open question. You have enough feedback, I think, to continue.
Okay, so that's it. I'm just want to push it. Okay, if you have any feedback and to make the next version for the draft, and happy to take any feedback or any comment, either face-to-face or on the mailing list. Thank you very much.
Thank you. Now Charlie is going to present our review report.
Let me know if you can't hear me. Pardon? Okay. How about that? Okay. Well, I'd like to just take 15 seconds to advertise the mentor program, and the reason I thought of it was because Mamoun, you may have noticed, is first-time attendee, and he came up and we talked, and so anybody here who would like to be a mentor, it's fun, so check it out. Okay. So I'm here to tell you about changes in the AODB Ripple spec. Really two things. One is we made a technical change to the protocol and some editorial modifications and improvements. And then second, we have an appendix in the document that describes implementation in a simulator, Kuja simulator. Now, I did not have any personal involvement with the code for the simulator, and it's actually, these should be considered to be preliminary results that should be published or submitted for publication sometime soon. But the code from the simulator, the plan is to release that, and it could form a reasonable basis for other implementations. So the main change that's a technical specification is that the instance ID in the route reply is always even. It was the previous version was allowed to be odd, but it turned out to be easier to understand and probably to implement if it's always even. And so there's an explanation about that, and I'll say more in just a minute. And then the other thing is details about what was chosen and the example topology and so on for the simulation. So the instance ID in the route request message is always odd, and as a result of that, if you pick exactly the next number for the instance ID of the route reply message, then you don't have to send back the target IP address because it'll be the same as was in the route request, and when the originator node gets the route reply, it'll know what target IP address was about. So this is a way of saving space in the route reply. So the normal case of the route reply is that the instance ID for that would be an even number and exactly equal to the value of the route request instance plus 1, and then you don't have to put the target node IP address in there. But it is possible to imagine conflicts so that the route reply should not have the next number, route request plus 1. So then the new modification is to just say, well, it still has to be even, and then you put it, set this T-bit, and when the T-bit is set, then you do have the target IP address in the route reply. So that's it for the technical update to the draft. And then in the appendix, there's a description of the simulation. They picked a sort of asymmetric question. Yes, Pascal?
Pascal, you lost me for a second here about this odd even route request was replied. Are you using global instance ID or local instance ID? Because basically, REPL has two types of instance IDs.
Uh-huh.
One which is global, so you have to know very well it's administered, right? So you know which instance ID you're using because you're programmed for it. So that cannot be a collision for the root reply, right? Because it's all designed for it. And then there is the local instance ID, which is basically the real instance ID is the concatenation of the IP address and a local number. And you have 64 of them because 2 bits are already used. And if you have this combination, then the guy who owns this address, who owns this namespace, knows if it's being used or not. But so I was wondering, if your root request is indexed by the requester, right, then it knows that even both the odd and the even numbers are free. If the root reply instance ID is also indexed with the same address of the guy who sent the root request, then there cannot be a collision. I mean, that's why I'm asking. You see, I don't see when the collision can happen. It looks like it's working every time.
Okay, well, my understanding was that the instance ID was local to the tree emanating from the device, and so
It's
it
local to the
was
root
maintained.
of-
But you know, if it's possible to avoid the by using the global,
No,
concatenation
I'm
of
saying you
IP
can
address.
use both, but in both cases you don't have a problem.
Okay,
Because I'm the root, right? I'm sending this route request.
right.
And when I select an instance ID, I will select an instance ID for which the odd and the even values, so I just select two numbers which are free in my namespace of 64. And so there cannot be a collision. As long as the root reply instance ID is built by the requester and this instance ID, this local instance ID, because the namespace is in both reply and request is taken from the source, not for the originator of the whole story, for the guy who sent the root request. So it's not the root reply instance ID should be taken from the namespace of the requester. That's what I'm saying, not from the namespace of the replier.
Well, but that's not. I don't think that's the way it is because we have this asymmetric problem, and it could be that the way from the originating node to the target is different than the way back. So I think that's why we had these two different, well, the local instance IDs. But I need to think about that. I'll go through that.
A whiteboard for a minute, because if we can save that discussion, that would be great.
Okay.
Thank you, Pascal. You have 1 minute more. Sorry.
Okay.
We are running
More
far.
faster. Okay. Well, I've already said the important parts. This is the topology. We need to do more topologies, or I should say they need to do more topologies. But you can see, anyway, it's purpose-built practically to allow a lot shorter routes than if you have to go, the normal Ripple way. So this is in the presentation. I don't really want to take time to go through it, but these are the simulation results about how Ripple actually manages to build a path versus AODV Ripple. And there's no surprises there. And then, well, there's no surprises here either that the AODV Ripple peer-to-peer is going to have shorter paths, which is anyway the whole point of AODV Ripple, except for, in addition, being on demand. So that's it. I'll check out the idea of the global uniqueness for the instance IDs. And other than that, it could be, I think it's ready to go.
Being further to my point, Charlie, it's not even the odd, the even bit we should be using, but if you're using local instance IDs, why it's only 64 values, because the first 2 bits are being used. First bit says global local, so you're local. Second bit says direction, right? So it's exactly that. I mean, if I want to establish a path to you, right? I'm sending this route request, and basically, if in this bit that is used for direction, I would set it from source. Now, when you do the route reply, you could actually flip that bit to indicate that is the route reply. You don't even have to use odd even values. There is a special bit to say the direction. So let's work out if we can use that.
Okay.
Thank you.
Thank you. Thank you for the
Thank you very much.
comments.
Michael? You have 1 minute. Sorry.
Take all your time.
Hi. So next slide. I rewrote the IPI&P security threats analysis, basically to say that we have this LLN full of devices willing to decapsulate packets with potentially forged addresses, and as a result, we should think very carefully about what we do. In particular, what it says, and I urge you to read it, is that the DUDAG routes had better do good BCP38 filtering, and if they do it well, then things will be just fine. But that there are some issues, particularly if you have efficient ND and across a backbone, because then you may have some things that are potentially in one LLN behind one route, another LLN that should be going through that would look like forged source addresses. So that's a concern. Please read it. And I think that was the last little bit of nit that we had from reviewers and stuff, and it's supposed to be going up the thing. So that was some of the text. Oh yes, and some of the stuff about it would actually be improved by DAO projection, because that because you're putting in IP headers in certain places, you may be bypassing shorter routes that you could have used. In some cases, that doesn't make sense to me right now, but Raul had a very good point. And anyway, DAO projection actually helps you a lot with that, to deal with the problem. And that was it. So, I don't know if we're going to have a hum. You want a hum? You can do that.
Yes. The document has gone through different phases, has had lots of comments, and I think it's really ready at this moment. So would the people who really think that this document should go further, to show their approval? Very good. I will send an email and I will ask those who hummed to confirm on the email that they think that this document should go forward. Are there any people who think it should not go forward? It's not ready? No? Okay. Thank you very much.
Okay, thank you very much. Please sign the brochures where they are. Thank you very much. I'm sorry for delay. 2 minutes. Thank you. Muchas gracias. Bien.
That's right. I told you. No, I told you. I've never seen this anyway. Oh, yeah, I told you. He's so short. He was over there.